All right, example 3. Cool. So it says, given that sine of theta is equal to 1/3 and theta is in the second quadrant, find the exact values of cosine theta, tangent theta, and secant of theta. Right? And so in order to do this, we're going to be using our trigonometric relationships and the Pythagorean identity. All right. And so the Pythagorean identity states that sine square of theta plus cosine square of theta is equal to 1, right? And it's given to me that sine of theta is equal to 1/3. So if I were to square that, I'll get that sine square of theta is equal to 1/9. All right. And so using the Pythagorean identity, I can rearrange this expression to solve for cosine of theta. And once I do that, right, using my inverse operations, I'm going to get that cosine of theta is going to be equal to plus or minus the square root of 1 minus sine squared theta, right? And the reason why we have plus or minus is because depending on what quadrant we're in, we're either going to want the positive root or we're going to want the negative root. All right, so which one is it going to be? Are we going to want the positive root or are we going to want the negative root of our answer, right? Select your answer now. Cool. So hopefully you guys selected the negative root, right? Since we're in the second quadrant, all our x coordinates are negative there. So we are going to want the negative version of this answer. Okay. So now I can plug in the value of sine squared, right, into my expression. And so I'm going to get that this is equal to negative square root of 1 minus 1/9. Okay. And I'm going to keep going. Then I'm going to have that this is equal to this negative square root of 8/9. And I can simplify this. I can simplify this a little bit more. And I'm going to get that this is going to be equal to negative square root of 8 divided by 3. So that is what cosine of theta is equal to. Cool. All right. And so next two things that I need to find is tangent of theta and secant of theta. All right. And so secant of theta is the reciprocal of what trig function? Sine or cosine? Cool. So hopefully you guys remember secant is the reciprocal of the cosine function, and we just found the value of it, right? So I can just take the reciprocal of it, and I will get the value of secant, right? So secant of theta is equal to 1 over cosine of theta. And I know that cosine of theta is equal to negative square root of 8 divided by 3, right? And I can simplify this out even more, and I'm going to get that this is equal to 3 over the square root of 8. But we don't really like to have radicals in our denominator, right? So we're going to multiply the top and the bottom by the square root of 8. And at the end, we're going to get our final answer, which is negative 3 times the square root of 8 divided by 8. That is what secant of theta is equal to. Secant of theta. Oops. Wanted to box my answer, but that didn't work out. But here we go. All right, so that's what secant of theta is equal to. Boom. All right, and one more. All right, and so now we want to find the value of tangent of theta. All right, and so remember tangent of theta is equal to sine of theta divided by cosine of theta divided by cosine of theta. And I already have the values of sine of theta and cosine of theta, right? Sine of theta, they gave it to me in the beginning. It was 1/3. And I'm dividing that by the value of cosine of theta, which is negative square root of 8 divided by 3. All right, and so I'm going to simplify this out, or I'm gonna multiply, or I'm gonna divide these two, and I'm gonna simplify. And so when I divide two fractions, I can take the reciprocal of the second one and turn this into multiplication. So I'm gonna get 1/3 times -3 over this divided by the square root of 8. And so at the end, I'm going to get -1 divided by the square root of 8. But remember, we don't like having radicals in our denominator. So at the very end, this is going to be negative square root of 8 divided by 8. And that is what tangent is equal to. Tangent of theta. Boom. All right. Cool. And so one last thing is besides these type of problems, we like to use trigonometric relationships and identities to like verify whether an expression is true or not. All right, and so here we have this like really nasty looking expression. I don't think we've seen something like this before just yet. It says, does cotangent square of theta times sine of theta divided by 1 minus sine of theta times 1 plus sine of theta equal to, is this equal to 1 divided by sine of theta, right? And so maybe like when you first look at it, you might be thinking like, there's no way this is going to be equal to one another. But we have to make sure. We have to be sure. And so what we're going to do is we're going to be using our trigonometric relationships and any identities to try to manipulate either the left side to look the left side of the equation to look like the right side of the equation, or vice versa, right? But being that we have a lot more to work with on the left side of this equation than we do on the right side, I'm just going to focus on the left side of this equation, right? So our goal is to manipulate the left side of this equation to somehow get it to look like the right side of this equation, right? Because if we do this, we'll be able to verify that this expression right here, the one that we have on the left, is in fact equal to 1 divided by sine of theta.